Chapter 7 Introduction to Algebra. Algebra is generalized of arithmetic. Algebra is a branch of mathematics that deals with variables, constants and algebraic expressions. Aryabhat, Mahavir, Bhaskar and Brahmagupta were the major mathematicians of ancient India. They contributed a lot to algebra and mathematics. Algebra deals with variables and equations. We have to find solutions or situations which have been represented through algebraic equations and inequalities. Understanding the basic logic. When variables, numbers and brackets are logically combined to represent a phenomena of science or mathematics, that expressions and reaction is called the basic logic. If algebraic expression y plus 7 upon 6 minus 12 etc. Let us take up a simple experiment. Take a box of mathematics. You can also take small sticks made of plastic to conduct this experiment. Make the following pattern with the help of 3 matchsticks. Note that you have to use 3 sticks to show the letter A of the English alphabet. Now scrap this A and create the second pattern as follows. From the given pattern, it is clear that you have made 6 A's. The total number of sticks used to make it 6 into 3 is equals to 18. Let us make a table now. Number of A's formed: 1, 2, 3, 4, 5, 6. Number of matchsticks used: 3, 6, 9, 12, 15, 18. We have skipped the exercise of making 2, 3, 4 and 5 A's from the matchsticks. We know that a relationship exists between the number of single pattern A's and the total number of sticks used to create them. Thus, we have number of matchsticks used is equals to 3 into number of A's created. Let number of A's created is equals to m. So, number of matchstick used 3m. We can use this simple expression to get the number of matchstick used for all patterns that are in the shape of A. In algebra, letters represent numbers. They are variables. They can acquire any value. Example, we want to create A 355 times using matchsticks. Number of matchsticks required is equals to 3m. Is equals to 3 into 355 is equals to 1065. Facts do you know? Here, m is a variable. It is always in lowercase letter in algebra. The numbers 1, 2, 3, 4 are constants. We use constants and variables in algebra. We use them to find out the values of variables. Example 1. The letter S of the English alphabet requires 5 matchsticks to get completed. Further, more sticks are placed to continue the pattern of S or reverse of S. Make a fine structure. Derive an algebraic formula for matchsticks needed to make S patterns, all connected to make a chain. Solution. The first S needs 5 matchsticks. The next S is to be placed in such a manner that it supports the pattern or first. So second S is an inverted S and it needs only 4 matchsticks. The first matchsticks of the new second 5 is the last matchstick of the first. This logic has been repeated. The final pattern has been shown here in the given figure. Let n number of S patterns in forward or reverse pattern. The other pattern needed only 4 matchsticks is equals to n minus 1. So the algebraic expression is number of matchstick needed is equals to 5 plus n minus 1, 4. In our case, n equals to 4. So number of matchstick needed is equals to 5 plus n minus 1 into 4 is equals to 5 plus 4 minus 1 into 4 is equals to 5 plus 3 into 4 is equals to 5 plus 12 is equals to 17. The given figure shows 17 matchstick. That is how we derive algebraic expression to solve problems. Constant and variables. There are 2 types of symbols in algebra. One, constant And second, variables. Algebra is based on the relationship of constant and variables. Let us define them. Constant. A constant is a fixed value of a real number that is part of an algebraic expression. Example, 2m is equals to 10. Here 2 and 10 are constants. M equals to 10 upon 2 equals to 5. So, m also is a constant in this example. The value of constant does not vary. Variable. A variable is an algebraic entity that can be assigned any value from the set of real numbers. Variables are used to do calculations in algebraic condition. Constant help them in this process. Example, 2m plus 4n equals to 10. If m equals to 1, n equals to 2. We get 2 into 1 plus 4 into 2 equals to 10. 10 equals to 10, which is true. Here, the value of the variable should be such that it satisfies the algebraic expression equality and inequality. Example, find to be given to school is equals to 100 plus 30 into n, where n number or days for which child remains absent from school. This value n can vary. The basic fine rupees 100 remains fixed for all children. If n equals to 3 days, we have fine to be given to school. 100 plus 30 into n is equals to 100 plus 30 into 3 is equals to 100 plus 90 equals to rupees 190. Facts to know. You can use variables like a, b, c, p, q, r, m, n, o, etc. or any other letter of the alphabet, but note that it must be used in a lowercase letter. Mathematical operations, symbols and inputs. All forms of arithmetic operations plus, minus, divide, multiply are valid in the calculations of algebra. Moreover, the brackets and powers of variable and constants are also used in algebra. Example, first, 2 power 3 equals to 8. Second, 2 power 3 equals to m power n is equals to n equals to 3, m equals to 2. Third, a plus b plus c plus d equals to 10. A plus b plus c plus d equals to 10. Fourth, 5x plus 7 equals to 37. X equals to 6. Let us revise some basic mathematical concepts and from basic arithmetic operation in the exercise that follows. We would need the same letter. Exercise 7.1. Question 1. A pattern of square is created in which the first square takes 4 matchsticks and subsequent patterns squares require only 3 matchsticks each. Develop an algebraic expression to calculate the number of matchsticks in the pattern with the given number of squares. 4 matchsticks required. 3 matchsticks required for all plus 1 addition for the first square. Question 1. Find out the algebraic expression. Solution: 3n plus 1 where n is equals to number of squares. B. Find the number of matchsticks needed to make such 12 boxes. Solution: 37. Question 2. Write the formula for calculating the perimeter of an equilateral triangle. Solution: 3s where s is equals to side. Question 3. Write the formula for the perimeter of the following. A square. Solution: P equals to 4s. B. A rectangle. Solution: perimeter equals to 2 into length plus breadth. Question 4. Write algebraic expression for the following. A. The sum of m and n. Solution: m plus n. B. 1 divided by p. C. Y upon 100 divided by 320. D. Subtract 105 from x. Solution: x minus 105. E. The sum of n and 422. Solution: n plus 422. F. The product of k and p. Solution: kp. Question 5. A room has 25 desks. Find a rule which should give the total number of desks in the room specified by us. Solution: D equals to 25R, where R equals to number of rooms and D equals to total number of desks. Question 6. Write the following as product. A. L plus L plus L plus L. Solution: 4L. B. B plus B plus B plus B plus B plus B. Solution: 6B. Question 7. Write the following as additions. A. 4x. B. 7x. Solution: A. X plus X plus X plus X. Solution: B. X plus X plus X plus X plus X plus X plus X. Algebra. The basic rules. The following rules are applicable. We assume that you are aware of the concept of constant, variable, arithmetic operators, parentheses, symbols, and inputs. Arithmetic expression: when numbers are connected to one another through basic arithmetic operators and brackets, they are together called arithmetic expressions. Example: 2 into 3 into 9 minus 5 into 3 plus 64. Algebraic expression: in algebra, we not only deal with numbers, we only deal with some letters also which represent different numbers. For example, formula in the generalized result of arithmetic, but we use letters to represent numbers from it. Suppose, example, we consider 3 circles of radius 5 cm, 6 cm, 7 cm respectively. So we can say or write radius r is equals to 5 cm, 6 cm, 7 cm. These r represents different number. Main features of algebraic expression: first, they have a few parts which may be constant or variables or both. Second, the every part of an algebraic expression is called term. In some terms like 9 upon 25 or 3 meter etc., the arithmetic operations may be missing. Third, algebraic expressions with only one term are called monomials. Example: 7p a upon 70 s power 2 minus 4r. Fourth, algebraic expression with two variables are called binomials. Example: n plus 4 and 7k plus 8 upon 10 are binomials having two terms each. In these cases, arithmetic operations have been done plus and minus in these two expressions respectively. Fifth, algebraic expression with three terms are called trinomials. Example: 4p minus 4q plus 80 and 12l minus 11m minus 25 are trinomials. Sixth, algebraic expression with more than three terms are called polynomials. They involve two or more variables. Constants may also be used. Example: 3p plus 11q plus 10r minus 12 and 6l plus 7m minus 8n plus 100 are the examples of polynomials. Seventh, the algebraic expression have the feature that only the variables of the same type can be added, subtracted, divided or multiplied. Two different variables can be multiplied, divided, added or subtracted, but they need more inputs or processing. They cannot give results if they have simple relationship or one algebraic expression. Only the idea is to calculate the value of one or more variables to satisfy a given condition or to achieve a particular result in mathematics or science. Deep calculations may be involved in higher classes. Rules for algebraic expressions. A. Commutative property over addition. If a and b are two real numbers, we have a plus b equals to b plus a. All cases must be considered to satisfy the rule. If a equals to 12, b equals to 8, a plus b equals to 12 plus 8 equals to 20. A plus b equals to 12 plus 8 equals to b plus a equals to 8 plus 12. This is called the commutativity of addition or variables. Also note that a plus 7 equals to 7 plus a. So the order of addition is not important. B. Commutative property over multiplication. If a and b are two real numbers, we have a into b equals to b into a. All cases must be considered to satisfy the rule. If a equals to 30 and b equals to 18, a into b equals to 30 into 18 equals to b into a equals to 18 into 30. This is called the commutation of multiplication of variables. Also note that a into 15 equals to 15 into a. So the order of multiplication is not important. See associative property over addition. If a, b and c are three real numbers, we have a plus b plus c equals to a plus b plus c equals to b plus a plus c. All cases must be considered to satisfy the rule. If a equals to 19, b equals to 17 and c equals to 31, we have a plus b plus c equals to 19 plus 17 plus 31 equals to 36 plus 31 equals to 67. A plus b plus c equals to 19 plus 17 plus 31 equals to 19 plus 48 is equals to 67. b plus a plus c equals to 17 plus 19 plus 31 equals to 17 plus 50 equals to 67. This is called associative property of variable over addition. Note that a plus b plus 15 equals to a plus b plus 15 is equals to b plus a plus 15. So the order of addition is not important. D. Associative property over multiplication. If a, b and c are three real numbers, we have a into b into c equals to a into b into c is equals to b into a into c. All cases must be considered to satisfy the rule. If a equals to 10, b equals to 12 and c equals to 5, we have a into b into c equals to 10 into 12 into 5 equals to 120 into 5 equals to 600. A into b into c equals to 10 into 12 into 5 equals to 10 into 60 equals to 600. b into a into c equals to 12 into 10 into 5 equals to 12 into 50 equals to 600. This is called associative property of variables over multiplication. Also note that b into c into 25 equals to b into c into 25 is equals to c into b into 25. So the order or multiplication is not important. E. Distributive property over addition. Let a, b and c are three real numbers. Thus we have a into b plus c equals to a into b plus a into c equals to ab plus ac. All cases must be considered to satisfy the rule. If a equals to 5, b equals to 8 and c equals to 11, we have a into b plus c is equals to 5 into 8 plus 11 is equals to 5 into 19 equals to 95. A into b plus a into c equals to 5 into 8 plus 5 into 1 is equals to 40 plus 55 equals to 95. This is called distributive property of variables over addition. Note that a into b plus 6 is equals to a into b plus a into 6 is equals to ab plus 6a. So the order of multiplication is not important. F. Additive identity of variables. If we add a variable to 0 or 0 to have a variable, the result is always the given variable. If a is a real number, we have a plus 0 equals to 0 plus a equals to a. So 0 is called additive identity. G. Multiplicative identity of variable. If use multiply a variable with 1 or if 1 is multiplied with a variable, the result is always the given variable. If a is a real number, we have a into 1 equals to 1 into a equals to a. So 1 is called multiplicative identity. Facts to know. The associative and commutative properties do not hold true for subtraction and division. Points to remember. Algebra is a branch of mathematics. It deals with variable, constants, algebraic expressions and equations. The letters used in place of numbers are known as variables. They do not have a fixed value and can be assigned any value. Any fixed number is a constant. Algebraic terms have constants and variables. Algebraic expressions are of more than one term. They represent mathematical and or scientific conditions. Algebraic expressions can be monomials, one term, binomials, two term, trinomials, three terms, and polynomials, more than three terms. Algebraic expression can be processed using addition, subtractions, divisions, and multiplication procedures. The algebraic variables follow the rule of associative, commutative properties in the cases of addition and multiplication, but not in the cases of subtraction and division. Exercise Question 1. Multiple choice questions. MCQs. Take the correct options. A. X plus 28 equals to 30. The value of x is first 8, second 2, third 12, fourth 2. Solution. Second 2. B. A into 1 equals to 1 into A equals to A. This is known as A. Additive identity of variables. Second, productive identity of constants. Third, productivity identity of variables. Fourth, multiplicative identity of variables. Solution. Fourth, multiplicative identity of variable. C. 3x plus 4y plus 8 equals to 0 is an algebraic equation whose number of terms is first 8, second 3, third 4, fourth 5. Solution. Second 3. D. Which one of the following is not true? First, A plus B equals to B plus A. Second, P into 3 equals to 3 into P equals to 3P. Third, fourth, A B plus C equals to AB plus AC. Solution. Third, E. Which one of the following is true? First, A plus U equals to 0 plus A equals to A. Second, L into 1 equals to 1 into L equals to 2L. Third, P into Q into R is equals to P into Q into R is equals to Q into P into R. Fourth, all of these are true. Solution. Third, P into Q into R equals to P into Q into R equals to Q into P Q into R. F. Find the value of the following expression if t equals to 0.3. Amount is equals to 0.2 t plus 11.7. First, 1176. Second, 11.76. Third, 117.6. Fourth, 11.72. Solution. Second, 11.76. G. The average speed of the car is x km/h. What is the distance covered in 17.6 hours? First, 17.6 upon x. Second, x upon 17.6. Third, 17.6. Fourth, none of these. Solution. Fourth, none of these. Question second. Make a table that should be based on the following algebraic expression. 2a cube plus 3. Solution. 12. Question 3. The present age of Jonathan D'Souza is 12 years. Find out the age of his elder brother who is 8 years elder to him. Also find out the age of his father who is 3.5 times older than him. Solution. Brother's age equals to 20 years. Father's age is equals to 42 years. Question 4. Represent the following statements through algebraic equations. A. 6 times a number is 1840. Solution. 6x equals to 1840. B. Thrice the number m added to 100 is 400. Solution. 3m plus 100 equals to 400. Question 5. Write the following as products. A. P plus P plus P. Solution. 3p. B. X plus X plus X plus X plus X. Solution. 5x. Hearts. Rolly read the algebraic expression 9pq plus 5ab. He said that this expression has 6 terms such as 9, p, q, 5, a, b. Molly said that there are only 5 terms as 9 and 5 are constant and form one term. What is your answer? Give reasons for your answer. Lab activity. Use only one value of x for all the boxes and complete the operations mentioned inside the boxes of this game. Write the result in the empty boxes that are connected to these boxes with the help of arrows.